Okay, we're going to go over GUIs today. Throughout the semester, I have said something to the effect that your unit test class takes the place of the GUI because most applications are going to have GUI. By GUI, I mean graphical user interface. You know, having a screen in which you can type stuff in and maybe select from a drop down or click a radio button or something like that. Most applications are connected to that. All right. You know, think of any application that you have. Most of it you run through a window on your computer that has a way of you interacting with the application, and you go from there. So we're going to start off with a very, very, very simple example, and we're going to build from there. Let's see. Okay, let me first compile it, make sure that it compiles, and then I'll run it. One directory deeper. Okay, so it does compile. And it's called first GUI. Now we're just going to learn the very basics of GUI. Designing good graphical user interfaces in Java can be a whole topic into itself. The University of Akron class that I teach, for those of you that are going to go on and possibly get a bachelor's degree, we go into a different way of doing GUIs than this, but we're going to go with sort of the tried and true, old-fashioned ways of developing GUIs. And we're not going to be terribly concerned about the appearance. We'll talk a little bit about that, but we just want it to mainly be functional, and we just want to connect rather our classes that we develop with our graphical interface. More on that a little bit later on. This one allows us to enter in a temperature in centigrade and calculate the equivalent in Fahrenheit. So if I type in 0 degrees centigrade and click convert, we get a message that says it is 32 degrees Fahrenheit, which it is. Fahrenheit, the freezing point is 32 degrees. In centigrade, the freezing point is 0 degrees. Boiling is 100 points in centigrade, and it's 200 points in, or it's 212 rather, in Fahrenheit. And sure enough, that's what we show. The formula is you take 9/5 of the centigrade temperature and you add 32. And that's what gives us the answer. So this is very simple, about as simple of an interface as you could create. Just a single text box or a couple of labels, a text box, and a button. So let's get into this. We're starting off by importing some classes. And the libraries that we are importing are both Swing and Sub for AWT. AWT and Swing are, again, older methods of doing user interfaces in Java. And we need all those things in order to do this. All right. Our class. Our public class, first GUI, extends JFrame. And we know what that means. That means that our class, first GUI, inherits from JFrame. So everything that is true about JFrame, all the functions, all the methods, and all that about JFrame are available in this class as well. All right. So let's look up JFrame. I'm going to type in the name of the class. This is the Java docs for it, and we see that it goes along the line of what this inherits from. And we can see the fields in it, the methods that it inherits. We can see the constructors. And we could see the methods that exist for the JFrame. Get used to reading these. I know these are a little bit hard to read at first, but get used to looking things up because these really tell you, this is the definitive, on Oracle site, the documentation on Oracle site is the definitive guide to Java. Tells you all the methods and properties that are available for a class. Well, I have my browser open. I want to ask ChatGPT a question.
Sometimes I don't even trust the AI stuff because it could potentially be incorrect.
You always have to scrutinize it, and it's like any other resource. You look for corroborating evidence. Do a reasonableness test. I mean, if it tells you something that is outrageous, be aware of that. But I found it to be very useful. Okay, have to confirm it on my phone. Yes, it's me. Okay. So let's ask it. Compare Java Swing and AWT with Java FX. A nice little summary, which is largely what I said. Looking up here, AWT is the oldest GUI toolkit in Java. Swing is built on top of AWT and has more sophisticated GUI components. And Java FX is the modern approach for that. And it goes on to give more detail. So Java FX is the newest, most modern one. And again, it's a little bit more difficult. So we're going to stick with Java AWT and Swing, specifically Swing. We use a couple of classes from AWT. So it extends that. So everything that's in JFrame, we get. It also implements active action listener. Let's look at the Java docs for that. All right. We know about interfaces. They define abstract functions. And in order to implement an interface, you have to have all the functions that are defined on that interface. In our case, we need an action performed button or action performed method, which accepts as an argument an action event of E and returns nothing. So let's look. Here we go. Has action performed that accepts an action event and returns nothing. So that's why we got a clean compile. If we didn't have that, it's not going to compile. All right, let's take it out for a second.
So just want to interrupt with a question. So is that, can you put back the, what is it? Can you put back the, no, on VS Code? Could you re-put that action args E or whatever it was? The one that you deleted previously?
Oh, sure.
The way I see this, I don't know why if I relate this to C#. Would this be something like some sort of like equivalent to a click event in C#?
Exactly. This would be the equivalent of a click event.
Oh, but in that case, it's like click event, because in C# it's click event, and then the event args E, and then in Java it's an action, right?
In Java, if you're using this method, it is an action perform method. And we'll see how that's used in a minute.
Yeah, I'm just relating some of this stuff from your class I took, so just one.
That's good. It's good to look for the equivalence for that. But as I was saying, if we got rid of this, then this is not going to compile. Why does it not compile? Because we implemented action listener and it does not have the action perform method. Put it back in and we get a clean compile again. All right, so sort of file that away in the back of your head that this has an action perform method. And what that's going to relate to eventually when we run this, it's going to relate to click, as you mentioned, clicking on a button.
Stays in the commit box.
So when I type something in here and click the button, that's when that action event occurs. Action performed event occurs. All right, let's look at this. First thing we do is we set visible to true. All right. If you remember the constructor for this initially sets windows to invisible. So the first thing we're doing in our window or our frame is to make it set visible to true. We're setting that when we close this, that we exit Java. So when I run this, when I close this, this application's done. Now, we create a panel. What's a panel? A panel is a collection of controls that we can add to our frame. So it's just a group of controls. And by default, when we create this group of controls, they're going to be, when we add them to the panel, they're going to be aligned horizontally. You notice everything is in a horizontal line. This, and when we type in something, our answer. Notice also that, well, we're getting a little ahead of ourselves, but if we type in something invalid, that we get an invalid input. All right, this is a critical line in this. Button convert, add an action listener, this. So what does that mean? Well, button convert is this button object that we create here. I forgot to show you this, but we have a label, a J label for enter this temperature in centigrade, the text field for entering in the temperature, a button that you click on to actually execute the code, and then finally a label for the results. So we have these 4 controls that are associated with our frame. Now, what this says is take this button and make it so that when you click on it, the code that's going to process the button click is in this class. Okay, that's what this means. This means this class, this object. So when I click on that, that's saying, hey, what's the code to process this? The code to process this is in this particular object. Okay, now what is that code? That code is right here, action performed. So the effect of this is what links the button to this code. We don't have to specify the name of the function. If we make it an action listener, Java knows that it's going to call the action performed event in whatever class we put here. Now, in this case, we have a very simple form. Everything's in one class. So I can make this implement that interface, and I can put in the action perform method. Because I implemented that, I can use this class object wherever an action listener method is required. So in this case, the button is setting the action listener object to this object, the object that's running. Now, if I got rid of this, we're going to have a problem as well. It doesn't compile. Why doesn't it compile? Because when I get rid of that implements action listener, I can no longer set this object as the listener object for this button. So this line blows up in compile mode. However, when I define that this implements action listener, that means I can plug this object anywhere that an action listener is required. Just like we did with interfaces. Remember, we made an array list of interfaces, and we're able to plug in that array list any object that implements that interface. So in the case of whatever lab number it was, we can create a light bulb, we can create a computer, we can create a television. And because they all implement our AC powered device, we can put them in an array that is expecting AC powered devices. Well, this function here is expecting something that follows this interface. So therefore, because this class follows this interface, then we can plug the object that's created into the action listener. So in a nutshell, this is what connects this button that's defined up here with this code. Because we're telling the thing that listens, the thing that is looking for something to happen or waiting for something to happen is for this button is this method. And when I click on that, this method gets fired off. So I'm going to add, so that's setting this up so that when we click the button, this code gets executed. We'll see another way to do that in a few minutes here. Now, we have our panel. I'm going to add the controls to the panel. So I'm going to add all four of these things. I'm going to add the label temp that says enter temperature. I'm going to add the text box for temp, which is a text field. I'm going to add a button for convert, btn convert, and we're going to add label results. Now, at this point, it's still not on the screen. It only gets put on the screen when we say, hey, take that panel and add it to my frames content pane. So if we were to do this, comment that out, it compiles, but nothing gets put on the page. They're all on the panel, but that panel is not associated with my JFrame. This is the line that does it. It takes that panel and adds it to my frames content pane. The content pane is what is available and what is seen within the frame. Finally, we set the size to be 800 wide, 100 tall. And that's where we are at. So we click the button, this code fires off. What does this code do? Put a couple variables. We try this. We try to get the data from the text box, what this line says, and we're trying to parse it as a double. Remember, a text box can have any text put in, so there's no guarantee that the user types in a number. They could type any text in. What this is doing is this is trying to convert the data that was typed in to a double. And if I type in something that isn't valid, I throw an exception. And what do I do with the exception? I set the text of the results label to invalid input. So I talked a lot about, like, whoever calls the object should catch the exception. Well, in this case, I'm calling the parse double. Therefore, I should be looking for any exceptions that the parse double can throw. And in this case, it would be a bad format exception. And I display that on the page. If it works, however, I do the math, multiply centigrade times 9/5 and add 32. And then I set the results text to the centigrade value or the Fahrenheit value plus the phrase degrees Fahrenheit. So to see it again from beginning to end, got to recompile it. Set it all from beginning to end. We click and we open this. We call that. Again, because we're executing it, that class, it needs to have a main event. That's a static method, so we are not required to have an object, the first GUI object yet. But that's what the main method does. It creates this window that's going to appear on the user's screen. So we call the constructor, first GUI, makes that window visible, says when we close it, we exit the program, creates a panel, defines that when we click that button, the code to process that click is in this object. We can only do that if this object implements the action listener. We then add these four things to the panel, add the panel to the frame, and set the size. It then sits there waiting for you to click the button. And when I click the button, one of two things can happen. If I type in something that can't be converted to a double, when I click that, action perform is going to execute. It's going to try these statements. If it receives an exception, pretty much the only thing that could go wrong in this case would be that I typed in non-numeric data. But if I throw an exception, it's going to display invalid input. If, however, I type in valid data, I then get computation. This computation done. It pulls the value, converts it to a double, stores it in C, does this math, and then outputs the double again. So that's our simple example. Now, I mentioned there's another way to associate an action listener with a button or something else. Did you have a question?
Oh, no.
Okay. All right. So let's look at the second way in the second example folder. I'm going to delete all of these guys. So you notice all I have now is the first GUI source code, first GUI.java. When I compile it though, I actually get two .class files. And we'll see why that happens in a couple minutes here. So let's look at the code for first GUI. All right, we have all these things. Let's run it and well, I compiled it. Let's run it and see what it does. I have two buttons. One is I can enter in the value in centigrade and convert to Fahrenheit. And the other, I can enter in the Fahrenheit and convert it to centigrade. So I have two buttons. Now those buttons do different things. So they're going to need different action listeners. All right. They're going to need different action listeners. Now, when we look at this, the first thing you notice is it extends JFrame, but it does not implement the action listener interface. What that means in a nutshell is I can't do like I did in the previous example and have an action perform method in this class. I could do it, but it's not going to do me any good because this isn't defined as an action listener. It doesn't implement that interface. So therefore, it would blow up if I tried to do it here or here. Now, how do I create an action listener? I do it two ways in this case. Normally, you wouldn't pick two ways to do it. I'm just using in this example, showing you two different ways that you could do it. Notice that in this class, there's actually another class defined. Now, throughout the semester, I probably have said that each class should be in its own .java file. If I said that, tack on the phrase most of the time to the end of it. Because this is a case where we're creating an action listener for this window, for this frame. And this action listener is always going to be associated with this frame. There's no point of making this reusable. So I define this right as part of the other class. So I set the listener for the C to F button to use a new C to F object. And what's that new C to F object? That implements action listener, so I can do that. Remember, if it didn't implement action listener, then I wouldn't be allowed to do this. But since C to F implements the action listener, I can do this. And this has the action perform method in it. So this will compile because I said it's an action listener and I included the action perform button or the action perform method, which is what this needs in order to be an action listener. So what does this do? Well, this is essentially the same code as we had before. Now, this is a class that got compiled and created this second file. The class C to F is part of the first GUI file, so that's how it represents that class. This is what's called an inner class. This class definition was made inside this class definition. So it's part of the bigger class. So when I compile it, that's why it shows like this. Because it's a class called C to F, and it is part of the first GUI class. Now, since no one else can use that class, that's an inner class, and we're writing it specifically for this window, we don't even have to define a new class. We can define what's called an anonymous class, and that's what we have here. And that's what this is, first GUI $1 class. That is the class information for this. In this case, we're setting the action listener to an object that we're defining right here. So we didn't define a new class like we did with C to F. We're defining a new action listener. And in order to do that, we have to have an action performed event or method in it. And we do that too. And this does the reverse calculation. So what this does is it assigns to that second button an action listener. And that action listener is this new object that we're creating here. It's called anonymous because we don't even give a name to that object. So it doesn't show any kind of name. We just define the action perform method that accepts an action event E, which we're allowed to do because it's an action listener. And then we have the code for this, which is, again, essentially the reverse calculation. So there's three ways that you can assign an action listener to a control. And in our case, usually we mean, when I say control, I usually mean a button. The one way is what we did in the first example. We made the frame itself an action listener and saying that it implements the action listener method. And then make sure we add the action listener or action perform method inside the frame. The other thing we could do is we could create an inner class inside of frame. So this class definition is part inside that our J frame that we create. And we give it a name. And it also implements action listener. Finally, we use an anonymous class. We create a class definition here that we don't even give a name to the class definition. We just say it's a new, it's an action performed, and it contains this stuff. So that way we have different things happening when each of the buttons are pressed. So something happening when that's pressed, something happens when that's pressed. Different things. So if we have two buttons, we're going to need two action listeners. We're probably going to need two action listeners. There is a way where you could combine all the code into one action listener and use the event to determine which button got clicked, but we're not going to worry about that for now. Now notice the layout of this. I had mentioned the layout by default is stacked horizontally. Well, this is stacked vertically. The reason for that is we set the layout of panel P to be along the y-axis. Along the y-axis, if you remember back from algebra, is up and down. So I created a panel. I actually created a couple panels. One called P and one called P2. P2, I just add the buttons to. So this is P2. P1, I first define that it's oriented vertically. Doing by doing this, we set the layout to be vertical. I add then the temperature label to it. I add the text box for temperature. I add P2. P2, what is P2? It's a panel that contains these two buttons. So we get those two buttons added to our panel P. Then finally, I add the label for results. Think of it like this. This is my frame. This is P, and this is P2. P2, we add the two buttons to. So those two buttons are there in P2. That P2 is floating in space somewhere. It's not anywhere on the screen. We then create the panel P and set the layout to be vertically oriented. So what do I put in it? First, I put the label. Then I put the text box. Then I put P2 in there. So I get the two buttons. Then I put the label for results. When I'm all done with that, I go and I set the content pane of the frame to be P. So that takes P and puts it within that frame. So that frame gets all these controls on it now. And when I click centigrade to Fahrenheit, this button, C to F, the action perform method in my C to F object gets called. When I click the F to C, the code in this anonymous class gets called. Now, it doesn't matter to me which method you use. You can make your frame, if there's only one button on it, you can make the frame implement action listener, you could make an inner class, or you can make an anonymous class. I want to show you where we're headed with this. If you have a chance, kind of look ahead. Because that's just a simple example that just has a little bit, just a snippet of code in it. We can actually write code that integrates with our other classes. And that's normally what we want to do. We want a separation between our user interface and our business classes. Something like student and course and all that. You call that a business class. Because remember, those business classes could be used all kinds of different places, not just in this GUI. We could have other programs that use those same classes. So we want to keep that logic in the business class and have the GUI just use that class. So what I have here is a little dice game. I have a dice game that has some classes. It has a dice class, a dice test class, and a high-low game logic, and then it has a GUI. So when I run this, All that's going to be in the GUI is the GUI stuff. All the logic of how to play the game and how to roll the dice and all that stuff is going to be in my business classes. So this contains the GUI. And the high-low game, you start off with 100 points. You predict whether the dice roll is going to be low. That's 2 through 6 when I roll the 2 dice. High, which is 8 through 12, or exactly 7. You get paid 1-to-1 if it's low or high. You get paid 4-to-1 if you predict 7 and it is 7. So I'm going to predict 7. Oh, and it was low, so I lost. I'm going to pick low. It's high, and I lost. But the GUI is just going to contain this stuff, and it's going to contain the code that connects the user interface to these other classes. So this is what we'll pick up next time. We'll look at this example and go through and see how a GUI can interact with other classes. All right, we'll either see you in lab or we will see you next week.
So I think you kind of already answered